Okay, this video is on solving polynomial equations by factoring, but this is the strategy of using the quadratic pattern. So we're going to be trying to factor down some perfect squares and some quadratics using sort of the pattern we've used in the past, which is our foiling method. Think back to when we did we just factored normal trinomials of the x squared form, where we used a is equal to 1. You'll remember that when a was equal to 1, we took all the factors of 8 over here off to the side, 1 and 8, 2 and 4, right? And then we tried to figure out which set, either the first set or the second set, would we be able to add or subtract those in order to equal a -2. And that's how we determined what would be going in our parentheses. This is almost identical to that situation. The only difference is that this is an x to the 4th pattern. So when you break down your parentheses like this and you get ready to, whoops, that should be a 0. When you get ready to think about how am I going to get those terms, because remember, this is the first 2 multiplied together, this is the last 2 multiplied together, and this is the outside and the inside combined to give you the -2. Well, to get that first term, that x to the 4th, what times itself again gives you x to the 4th? So if you were using a chart or a note card or something and you had your perfect squares and your perfect factors and those things on it, perhaps you had an x squared times an x squared. And remember that when you are multiplying polynomials together or terms together, you have to add the exponents, so we get x to the 4th, right? So x squared times x squared gives me x to the 4th. Those go in here. Just like when we did the regular ones where we said x times x is how we got x squared in our normal trinomials. This one is just elevated a little bit larger numbers. And then which set of factors of 8 are going to give me a -2, okay? So if I use -4 and +2 and I add them together, they're going to give me -2 in the middle, and +2 times -4 is going to give me -8 for my last. So I'm going to put them in here. And then I'm going to check. First, x squared times x squared is x to the 4th. And then last is 2 times -4. That is in fact -8. So first and last check out, and now I just need to double check my outside and inside terms. So -4x for outside plus 2x squared for inside. So -4x squared plus 2x squared is -2x squared. So the O and the I check out as well. So all is good. And then what we do from this point on is we just set those factors equal to 0. So we're using the zero product property. So x squared plus 2 equals 0. X squared minus 4 equals 0. Set both factors equal to 0 and solve. So subtract 2. X squared equals -2. To undo an x squared, we do the inverse of it, so we square root it. So I'm going to square root the x squared. I'm going to square root the -2. Any square under a square root cancels. And then, of course, the only thing I'm going to be able to take out of this particular radical is the I for the -1. So the -1 comes out as an I, and we just leave the 2 in here. Plus or minus. Don't forget, when you're taking the square root of things, you need plus or minus, okay? And then over here, we're going to add 4. And we get x squared equals 4. And again, square root both sides to undo the square. They are inverses. The square root of 4 plus or minus 2. So again, we have actually 4 roots here. Look at your quadratic. The highest term is a 4th power. So that should be a big hint to you that we have 4 roots, plus or minus I square roots of 2, and just plus or minus 2. So 4 roots there. So I'm thinking that you'll probably do okay with this process if you just kind of keep in mind that we are sort of undoing the foiling process. Okay, so let's try a couple. Let me clear the screen and scroll up for you. And we'll just try a couple of these. So 2 examples. I don't save myself a lot of room to write here, so let's see what I can do. Again, it's a quadratic to the 4th power, so I'm just going to, a is 1, so I'm just going to go ahead and put my parentheses down. I need the factors of 6, 1 and 6, 2 and 3. Okay. Again, think first, last, and then this is the combined outside inside. So how do I get an x to the 4th by multiplying two things together? X squared times x squared gives me x to the 4th. Okay? Now, which factors of 6 are we going to use to get a positive 7? I would say positive 1 and positive 6 added together gives me positive 7. Now, let's check before we move on. First, x squared times x squared, x to the 4th. That checks out. Let's look at our last terms. Plus 1 times plus 6 is plus 6. That works out. And then my middle terms, I have outside 6x squared, inside 1x squared. Add them together, 7x squared. The O and the I work out. So I've done my job here in breaking this down into the two binomials that would have formed that trinomial. So we're undoing the FOILing process. Very nicely done. Then we're going to take each set of parentheses and set them equal to 0. X squared plus 1 equals 0. X squared plus 6 equals 0. And from this point on, it's solving. So we're going to subtract 1, isolate the variable, and then we're going to square root both sides of the equation. And they cancel. They're inverses, and we get x. And the square root of negative 1 is plus or minus I. Subtract the 6 in this equation. X squared equals negative 6. We need to square root both sides of the equation. X equals. I can take the negative 1 out as an I. If you think about how 6 breaks down, 2 times 3, we're not going to be able to have any pairs that we're going to be able to rewrite as perfect squares under a square root in order to cancel them and bring them out from underneath the root. So there's no point in rewriting it. Just going to take the I out and make the root now positive. And so our 4 roots are plus or minus I and plus or minus I square roots of 6. There are your roots. Let's do this one over here. So, again, a trinomial to the 4th power. So be thinking first, outside, inside, and last. So I'm going to put my parentheses down because it's a equals 1. So I can just go ahead and set my parentheses down. What times itself gave me x to the 4th? X squared times x squared. And then I need factors of 10. So 1 and 10, 2 and 5. And I'm trying to get a negative 3. So negative 5 plus 2. And check. X squared times x squared, that is my first term, x to the 4th. My last term, positive 2 times negative 5 is in fact negative 10, so my last term works out, and now I just need to check my outside inside. So negative 5x squared and positive 2x squared is negative 3x squared, so those also work. Set them equal to 0. So subtract 2. X squared equals negative 2. I need to square root both sides. Whoa. I need to square root both sides to make sure that I am undoing the square process. These are inverses, so they cancel. X equals, again, I can't take anything out of the 2. There are no factors that will come out, but I can take out the I. So plus or minus I square roots of 2. And let's go ahead and look at the second one. Add 5. So I have x squared equals 5. And again, square root both sides of the equation to undo the square. So x equals, I can't take out that 5, so plus or minus square root of 5. So my roots are plus or minus I square roots of 2 and plus or minus the square root of 5. There are my 4 roots.